Hello again. Today we're just going to do the Newton's law of universal gravitation. So the question is, there is a diagram, the Earth and the satellite, and then there is a distance between the Earth and the satellite. So a satellite of mass 980 kg is orbiting the Earth at a distance of 160 kilometers from the surface of the Earth, as shown in the diagram below. So before we can start calculating, we must make sure that we converted the distance from kilometers to meters. So this one is 160 kilometers. So 160 kilometers, to convert the kilometers to meters, we just multiply by 1000. So that means this one is going to give us 160, we can say 10 to the power 1, 2, 3 zeros. So that is 10 to the power 3 meters. So now the distance between the Earth and the satellite is 160 times 10 to the power 3 meters. 5.1, state Newton's law of universal gravitation in words. So without the waste of time, we can just state without writing it down, but stating the laws and the definitions, you make sure that you find it from the exam guideline. We don't just take any definition or any law from the textbook or the study guide. We take it from the exam guideline. So according to Newton's law of universal gravitation, every particle in the universe attracts every other particle with the gravitational force that is directly proportional to the magnitude of the masses and inversely proportional to the square of the distance between their centers. So according to the Newton's law of universal gravitation, this is the formula we're talking about. So let's just go straight to 5.2. 5.2, they said calculate the magnitude of the force that the Earth exerts on the satellite to keep it in orbit. So now, before you start, you go to your formula sheet. You check what is given. So we have the formula here. F is equal to G m1 times m2 divided by d squared, or you use r squared. So that's not a problem. That means 5.2 F is equals to G m1 m2 over r squared, or you can use d squared. That's not a problem. So now let's check. What is G? G is a universal gravitational constant from the table. So you go to the table, this is your G as 6.67 times 10 to the negative 11. So you just go straight. G 6.67 times 10 to the negative 11. Close the bracket. And then we open the bracket for M1. M1, let's say that is our satellite. So now, what is the mass of the satellite? The mass of the satellite, they said, is 980 kg. So we go straight 980 kg. And then M2, let's say that is the mass of the Earth. So from the statement that there is no mass of the Earth, that means the mass of the Earth, it is given on the table. So you go to the physical constants table, you check, this is the mass of the Earth. Mass of Earth. So mass of Earth is what? 5.98 times 10 to the power 24. So now this is 5.98 times 10 to the power 24. And then we divide. Now, what is the distance between the Earth and the satellite? The distance they said is 160. So we converted it to 160 times 10 to the power 3. So this is 160 times 10 to the power 3 plus. Why plus? Because we're talking about the Earth here. And what is the radius of the Earth? The radius of the Earth is 6,38 times 10 to the power 3. So this one is in kilometers. To convert it to meters, we just multiply by 1000 here. So 6,38 times 10 to the power 3, then times 1000. Then this one's going to give us 6,38 times 10. This one's to the power 3, this one to the power 3. That means now it's going to be to the power 6 meters. So now we just go and say 6,38 times 10 to the power 6. This one now it is in meters. And then we square. So now we just punch the calculator, this, just multiply by that, and then we divide. And then the answer is going to be 9138,98 Newton. Since we're talking about the force, so the unit for force is in Newton. Now 5.3. Calculate the weight of the satellite on the Earth's surface. So the formula for weight is equal to mg. So if you don't remember, you just go to your formula sheet. We have weight here. Weight is equal to mg. So you just go straight and take it on the formula sheet if you don't remember it. So now, since they're talking about the satellite, so the mass of the satellite, it was given as 980 times. Then g, we're talking about the Earth. So this is the gravitation acceleration on Earth, which is 9.8. So from here, the answer is going to be 9604 Newton. But since the question said they calculate the weight, so weight is a vector, right? And weight is always downwards. That is the direction of the weight. So we can say downwards. They did not say the magnitude. They just said weight, and weight is a vector. That means there's the magnitude and the direction. Now 5.4. Now we must state three differences between the mass and the weight. So on this one, we can just draw the table. Maybe it will be easy. We can just draw the table. Let's see. This is the table. Oh, divide, yes. So this one, let's call it weight. This one, let's call it mass. So the first point on weight is a vector. We agree on that. So since it has the magnitude and the direction, that makes it a vector. But mass is a scalar. It doesn't have the direction, only magnitude. So mass is a scalar. This is a scalar quantity. So we can say a scalar quantity. This one is a vector quantity. So point number 2, we can say weight is measured. It's measured in Newton. Can write capital letter N in bracket. So the unit for weight is Newton. Now, but mass is measured in kilograms, which is kg in brackets. That is the kilograms. So the last one, since they said the three differences, now we can say weight. Weight is, remember, weight we call it, sometimes we say is Fg, right? So this Fg, that is the gravitational force, or the force of gravity. So weight is a gravitational force, or the force of gravity. Let me call it the gravitational force exerted on the object by, exerted on the object by the Earth's surface. So the last one, the first one, weight is a vector quantity, mass is a scalar quantity. So the second one, weight is measured in newtons, mass is measured in kilograms. Then the last one, weight is a gravitational force exerted on the object by the Earth's surface. So this is the definition for weight. That means now mass is an object's magnitude, or the magnitude is the magnitude on an object. So these are the differences between weight and mass. So this is the end of our questions. So thank you for watching, and please subscribe.